Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class we have discussed about heat. We have given an introductory concept about the heat, and we have also briefly stated about temperature. Today we are going to discuss a few more things about temperature. We are going to know about the SI unit or the other units of temperature. Okay, and we are going to understand how temperature is different from heat. Okay, fine. So let us quickly move on to the topic. So before stating the units of temperature, first of all let me tell you another thing that about temperature. Okay, so what is that? See, we have said that heat energy is actually the sum of the total internal energy of the molecules or the particles present inside a matter. Now, how is temperature related to that heat? Okay, how can temperature be related to the heat? Okay, so basically temperature. See, we cannot directly measure the kinetic energy of the molecules present in a matter. Is it possible? But definitely we know that the molecules present in a matter are in continuous random motion. It may be solid, liquid or gas. In solids the motions are bit less, in liquid the motions are more, and in gases the motion is very random and the most. So basically we know that there are some kinetic energy associated with the randomly moving molecules, but can we directly get a measure of the kinetic energy? The answer is no. So how can we but there is an indirect way by which we can at least get an idea, at least get a concept about temperature. Okay, so how can we actually define temperature? So basically temperature can be defined as like this, that it is the representation of the average kinetic energy of the molecules. Okay, so temperature is the representation of the average kinetic energy of molecules of a matter. Okay, we can easily denote temperature like this also. So you can easily understand, more the randomness of the molecules, more is the temperature. So definitely we can write this, that more the randomness. Okay, so more the randomness. Okay, so more randomness. Okay, so more is the temperature. Okay, remember this thing. More is the randomness, more is the temperature. Okay, so more the molecules are moving, definitely for a particular matter, more the molecules are moving rapidly, more is the temperature. Okay, fine. So actually see, when you start heating an object in a solid state, what happens? It slowly gets heated up, and then after a certain point it starts melting. Why it starts melting? Because when you are heating the molecules, the energy that you are giving, that causes an increase in the kinetic energy of the molecules. As a result, the randomness increases. As a result, you can see that if you just keep a thermometer in contact with that object, you see that the temperature is rising. So why the temperature is rising? The answer is that the kinetic energy of the molecules keeps on increasing. So basically temperature of a body is the representation of the average kinetic energy of the molecules present in a body. Now, so this is the concept about temperature. Now if we just think of what are the units of temperature, basically temperature is measured in various scales. Okay, so temperature is measured in various scales. What are the scales? Let us just quickly have a recap of the scales of temperature. Okay, so the scales that uses temperature, there are three scales basically. Okay, three scales. One is the degree scale, so Celsius scale. Sorry, it's the Celsius scale. Celsius scale. Okay, another one is the Fahrenheit scale. Fahrenheit scale, and the third one is the Kelvin scale. Okay, Kelvin scale. Now, these three scales have different number of divisions. Okay, in Celsius scale, what you see that all these scales have a steam point and ice point. What is steam point and ice point? See the particular value in a particular scale at which water freezes into ice, or rather say ice melts into water. That point is called the ice point. Whereas the particular value for in a temperature scale where water starts boiling and gets converted into steam is called the steam point. So if I consider these three scales, for Celsius scale the ice point is 0 degree Celsius and the steam point is 100 degree Celsius. Okay, for Fahrenheit, what is the value for Fahrenheit? For Fahrenheit, the ice point is 32 degree Fahrenheit and the steam point is 212 degree Fahrenheit. Okay, whereas for Kelvin scale, the ice point is 273 Kelvin, whereas the steam point is 373 Kelvin. Now, note one thing, that while you have written the temperature in Kelvin, we have not used the symbol of degree. Okay, remember that when you are expressing temperature in Kelvin, you should not use the symbol degree. Degree is used for Celsius and Fahrenheit scales only. Okay, so from this you can conclude, you can draw inference that the Celsius scale have basically 100 divisions. Okay, 100 divisions in between the steam point and the ice point, 100 divisions. Okay, for the Fahrenheit scale there is 180 divisions in between the steam point and the ice point, whereas for Kelvin scale again there are 100 divisions in between the steam point and ice point. Okay, so these are the three basic things that you must know. So if you are measuring a change in temperature in the Celsius scale, say you have taken you are saying that the difference of temperature between two temperatures in the Celsius scale is 50. Okay, so in the Kelvin scale it should be also 50, but in the Fahrenheit scale it should have a different value. Okay, so we will be discussing this through a numerical problem. Okay, so basically very in a simple language you can say that, say you are saying that the difference between two temperature points is 50 or say 40 Kelvin, then it should be the temperature difference should be same in the Celsius scale also, because 100 divisions, both the Celsius scale and Fahrenheit scale, Kelvin scale had 100 divisions between the steam point and the ice point. So that is why difference in temperature in the Celsius scale and Kelvin scale are equal, are same, but not the same in the Fahrenheit scale. Okay, so we will do a numerical problem where we will be understanding this concept in a more rather concentrated way. Okay, fine. Now, so these are the units or scales of temperature. Now, how are these temperature scales related? If you have to convert the temperature given in one scale to another scale, how are these scales related? Okay, see, basically when you are calculating the temperature in Kelvin, okay, temperature in Kelvin you want to calculate, and you know the temperature in degree Celsius, so temperature in degree Celsius plus 273 gives you temperature in Kelvin. Okay, so if you say have, for example, I am saying that I have a temperature of say 20 degrees Celsius. So what should be its equivalent value in Kelvin? It should be plus 273. That means it is 293 Kelvin. And say if I have a temperature in the Kelvin scale and convert to degree centigrade, so degree centigrade is equals to temperature in Kelvin minus 273. Take another example. Say we have a temperature of say 473 Kelvin. So 473 Kelvin when converted to degree Celsius, it's minus 273. So 200 degree Celsius. Okay, so this is how we can convert the temperature in Kelvin scale to centigrade scale. Now, if I say what is the temperature from how can you convert the temperature in degree Celsius to Fahrenheit scale? Okay, so how can you convert? Let us see. So there is a particular formula. Okay, so what is the formula? But remember this. So it's like this: C by 5 is equal to F minus 32 by 9. This is the formula that relates the temperature in the Celsius and the Fahrenheit scale. So if I say have a temperature of, say let's say take another example, let's say I have a temperature of 150 degrees Celsius. Okay, so put the value of 150 in the place of C. 150 by 5, it's 30. Okay, so how can you convert this temperature into Fahrenheit scale? Say, let us see. So it should be, calculation should be like this: 150 by 5 equals to F minus 32 by 9, isn't it? So it's 30 here. Okay, so we can write F minus 32, 30 multiplied by 9, it gives 273. So to get the temperature in F, you have to add up this 270 with 32 and you get 30, 300 and 302. So temperature in degree Celsius scale, 150 degree Celsius, a temperature is equivalent to a temperature of 302 degree Fahrenheit. Okay, so in this way you can also convert any temperature given in Fahrenheit scale to degree Celsius scale also. Okay, so I hope the relation on the conversions are clear. Fine. Now let us quickly move on to the next topic. See, if you have not written it, please pause the video, note down the concepts and then move on, or just as resume the video. Okay, now next thing that we are going to discuss is the expansion, or the say rather thermal expansion. So what is thermal expansion? First of all, let us understand what is thermal expansion. It's very easy. Now see, when you heat or give heat to an object, okay, what happens? What can you expect? You can expect that the temperature of the object can increase, isn't it? Temperature of the object can increase. Okay. Second thing that you can expect is there can be a change in the state of the substance. Solid may get converted into liquid, liquid may get converted into gaseous state, like this. And the third thing that can happen is that there can be an expansion of the substance. What is expansion? That is increase in its dimensions is the expansion what we are trying to mean. And as this is the due to supply of heat, due to giving of heat, definitely it's called thermal expansion. Okay, so it's thermal expansion. Now, so what are the actually how can you define thermal expansion? So when there is a change in the dimension or increase in the dimension of an object on supplying heat, so increase in dimensions rather of an object on heating, okay, increase in dimensions of an object on heating is actually called thermal expansion. Okay, so basically there are three kinds of thermal expansion. See, for very things like, so just let me briefly give you one concept. Three kinds of thermal expansion are there. One kind of thermal expansion is called the linear expansion. Okay, linear expansion. What is linear expansion? Now, if you have an object like say a rod or a structure like this, the pen. Okay, you have an object like this. Now, the length of this pen is actually far greater than the other two dimensions of this object. You know that any solid object that you are holding in your hand has three dimensions: length, breadth and height. So if you consider this pen, the length of this pen is considerably greater than the other two dimensions of the pen. Okay, so in case you heat this kind of substances, what happens? This kind of substances increase in only length, and that expansion is called linear expansion. So increase in length. Okay, now the second kind of expansion is called the superficial expansion. Superficial expansion. So what is this expansion? If you take any object like say a thin plate, okay, a thin plate. So you know, for a thin plate, the length and breadth are considerably larger than the thickness or height of the plate, isn't it? So in this case, if you heat a plate, what happens? Mainly the expansion is seen in the area. The length and breadth increases. As a result, we can say that the area has expanded. This kind of expansion is called the superficial expansion or area expansion. And the third kind of expansion, it's called the volume or cubical expansion. So the third kind of expansion is cubical expansion. Cubical expansion. So what is this expansion? You take a solid cube which has all the three dimensions in considerable amount, length, breadth and height, and then if you hit that object, you see that the length, breadth and height, all the three things expand for this kind of object. Now this kind of expansion is actually called cubical expansion. So I hope the concept for thermal expansion is clear. Okay, so today we will be stopping here. In the next class we will be discussing about the anomalous expansion of water, and we will be doing some problems, numerical problems on the conversion of temperatures. Okay, so with that we end our class today. If you have any query, any doubt, please do mention it in the comment box. We will be happy to solve your problem. Thank you for watching. Thank you. Goodbye.